Number one, we are looking for what values of x would end up causing you to divide by 0. So you factor x squared minus 9, since it's a difference of two squares, you get x plus 3 and x minus 3. So what would cause that to be 0? Well, either x plus 3 would be 0, or x minus 3 would be 0, which means x would either be negative 3 or x would be positive 3. Either one of those two values would cause you to divide by 0 and therefore be undefined. Number 2, we're going to change that to multiplication and flip the second fraction. So we get x plus 8 and x minus 8. When you factor the denominator of the first one, the x cubed goes on bottom, the x plus 8 goes on top, the x plus 3's now cancel each other out, the x plus 8's cancel each other out, and you're left with 1 over x minus 8. Number 3, this is multiplication, so you don't have to flip it, but we need to factor everything. Top factors into b plus 2 times b minus 1. The bottom factors into b minus 5 times b minus 1. The second fraction, the top factors into b plus 5, b minus 5. And the bottom factors into 6 times b plus 2. So then you go through and cancel any common factors like b plus 2 on top and bottom, b minus 1 on top and bottom, b minus 5 on top and bottom, and you're left with two factors that don't cancel, of b plus 5 over 6. For number 4, we're going to change this to multiplication. The 3m squared minus 75 factors into 3 times m plus 5 times m minus 5. The 6m squared plus 30m factors into 6m times m plus 5. And then we're going to change this to multiplication. The 8m squared plus 40m will go on top. The 8 and m will factor out. We're left with m plus 5. And in the bottom, we have the 4m minus 20, which factors out of 4, and you get m minus 5. So before we do our multiplication, let's look for common factors again that'll cancel. We have an m plus 5 in top and bottom. We have an m in top and bottom. We have an m minus 5 in top and bottom. And we're left with 3 times 8, which is 24, times m plus 5 over 6 times 4, which is also 24, which will cancel, and your answer will just be m plus 5. Number 5, we need to get a common denominator. Since x squared minus 4 factors into x plus 2 times x minus 2, then I need to multiply this fraction on the left by x plus 2 over x plus 2. And I'll have a common denominator at that point, and so I'll add 2 times the x plus 2 minus 8 over the x plus 2 times x minus 2. This numerator simplifies into 2x plus 4 minus 8 becomes 2x minus 4 over x plus 2 times x minus 2. The 2x minus 4 in the numerator, you can factor out a 2. You get x minus 2 left over, and that will cancel with the x minus 2 in the bottom. And so my final answer is 2 over x plus 2. Number 6, the denominators are almost the same except opposite signs in front of these. The 3m is positive, here the 3m is negative. On this one, the 1 is negative, here it's positive. So if I multiply the second fraction by negative 1 over negative 1, then that will give me a negative 1, positive 3m, and a minus 2. So that makes it 5 minus 2 over the positive 3m minus 1, which becomes 3 over 3m minus 1. Okay, number 7, 4 times 9. 4, 9, and 18, the least common multiple of 4, 9, and 18 is 36. And then I have m's and p's. I have m to the third, m to the first, and m to the fourth. I'm going to use the largest exponent. P's, I have p to the first, p to the fourth, p to the second. I need to use the largest exponent. Number 8, I need to factor these down to figure out what factors I need to include in my least common multiple. So that factors into n minus 6, or n minus 4 times n plus 2. This factors into n plus 6 times n minus 4. So all of the factors listed out, I have an n minus 4 that shows up, I have an n plus 2, and an n plus 6. So I need my final answer to contain all three of those, n minus 4, n plus 6, and n plus 2. The next one, we're looking for vertical asymptotes. A vertical asymptote is going to occur whenever x is, whatever value of x will cause you to divide by 0 and make it undefined, as long as this fraction is simplified. This fraction is simplified, so x minus 3 equals 0 when x is 3. So that is going to be the equation of your vertical asymptote. The next problem asks for points of discontinuity. So in points of discontinuity, you're also looking for values of the denominator that would make it 0, values of x that would make the denominator 0, but those values would need to also make the numerator 0, basically. So since the numerator factors into x minus 4 times x plus 2, then since the x plus 2's would end up canceling each other out when we reduce, x equal to negative 2 would cause the denominator to be undefined, and it also caused the numerator to be 0. So that would make it a point of discontinuity. Number 11, when you put the equation into the calculator, you would end up having points from the table around these locations. And you look at the graph, and the graph is going to bring it around this way. And also, you have points around these locations, which would bring this edge of the graph around this way. Y varies jointly as x and z, then that means your equation would set up as y equals k times x times z. So solving for k would make it y over x times z equal to k for both situations, and they're both equal to the same k. The same value of k works for both. So you can have 2y over x times z's set equal to each other, and for the two situations to help you find your unknown. So in the first situation, y is 6. When x situation, we don't know y, but we know we want to find out what it is when x is 24 and z is 5. So when you cross multiply, you get y times 4 times 12 equal to 6 times 24 times 5. So you would need to simplify that down. 6 times 24 times 5, all divided by 4 times 12 is 48. Put that in your calculator. Then you'll get the value of y. I believe it is 15. For number 13, 5,000 households. Currently 5,000 households have high-speed internet, and 80 customers have their online photographs delivered. So if this is proportional, if this trend continues, what's it going to be at 12,000 households with high-speed internet? So if 80 out of the 5,000, how many can we expect when we reach 12,000 households with high-speed internet? So again, you can cross multiply and solve for the unknown. 80 times 12,000 would be equal to C or X times 5,000. So divide both sides by 5,000. And you should get C equal to 192. Number 14, y varies inversely as x. So y is equal to k over x. That means k is equal to y times x, in both situations. And the k is the same in both situations. So if k is equal to y times x, or y1 and x1, and k is also equal to y times x in y2 and x2, then we can set them equal to each other, because they're equal to the same k value. And we plug in the numbers from the two situations. So in the first situation, y is 25. When x is 6, we want to find y when x is 150. So this is how it looks when you do an inverse variation. It's not quite like a proportion. It's kind of opposite of a proportion. So divide by 150. 6 times 25 is 150, so you get y equal to 1. Number 15, the percentage of wildfires that are uncontained varies inversely with the amount of precipitation. What that means is there are more uncontained fires when there's less precipitation, and less uncontained fires when there's more precipitation. So that's how they vary inversely. So if we want to express an equation, or write an equation that expresses P, the percentage of fires, as a function of A, then P would be equal to K, your constant, over A. That would be P as a function of A. Number 16, you have a variable on top and a variable on bottom, so that would make it a combination. That would make it a combined variation. On number 17, you only have a variable on top. So this is kind of like having 1/7 m. We're not dividing by m. Since we're multiplying by m, that makes it a direct variation. For number 18, we're going to subtract 2 over x minus 2 from both sides. Sorry, 2x. We can do that because we have a common denominator here. And we would be left with, still have, those cancel, we still have x over on the left. And we get 3x minus 2x, which is just 1x, minus 2 over x minus 2, which is equal to 1. The other way to look at it is to multiply everything by the least common multiple of the denominator. So if you multiply everything by x minus 2, then that's one thing you're allowed to do. Then you're left with x times x minus 2 plus, these cancel, so you're left with just the 2x, equals, these also cancel, the 3x minus 2. And this ends up being x squared minus 2x plus 2x equals 3x minus 2. Right here, those two will cancel, and we'll be left with x squared equal to 3x minus 2. And when you set that equal to 0, you get x squared plus 3x minus 2, which factors into x. Need to back up for a second. We need to bring, if it was positive over here, this would make it negative over here, and that's going to mess with everything a little bit. So we're going to take, instead of taking the x squared to the right, we're going to take everything else to the left. So it'll be x squared minus 3x plus 2 equal to 0. And that would factor into x minus 2 and x minus 1. So that means that x could either be positive 2 or x could either be positive 1. But the reason that this won't work is because back here, it is one of our numbers that would cause us to be undefined. So that's why it can't be that, it can only be that. And number 9, you can either subtract 2m from both sides, but your first step is to identify that m equals 0 is going to make it undefined. Okay? Then we need to solve for m as if it was an equation, and if you multiply everything by m, or if you subtract 2m from both sides, 2 over m from both sides, either way, you're going to eventually get 9m equal 45. So when you divide, m would be 5. So those are the two numbers on the number line that will separate it into 3 different regions, 0 and 5. So we need to test a number within each region. We're going to test -1, we're going to test +1, and we're going to test 10. So when we put -1 into this equation, -1 in for m, does this become, is this a true statement or a false statement? Well, that becomes 9 minus 2, and that becomes -47, which is 7. Is 7 greater than -47? Yes. So that means this region would have values of m that would satisfy this inequality. Let's test the middle. What if m was a positive 1? Well, it would be 9 plus 2, and it would be a positive 47. Is 11 greater than 47? No. So that means all the numbers in this region do not satisfy. If one number in that region doesn't, then all the numbers in that region won't. Now we go to the last region. What if m was 10? Well, we get 9 plus 0.2, it's 2/10. Is that greater than 47 divided by 10 is 4.7. Okay, 9 plus 0.2 is 9.2. Is that greater than 4.7? Yes. So that means my answer is going to be m needs to be less than 0 or m needs to be greater than 5. And number 20. 2 ways to go about this. You can either factor the denominator, you factor out an x, and you get x minus 6. And the x's will cancel. And when the x's cancel, you're left with 1 over x minus 6 equals 1. Multiply both sides by x minus 6. Those will cancel, and so I'll get 1 equals, and on the right side, I have 1 times x minus 6, which is just x minus 6. Add 6 to both sides, and I get 7 equals x. The other way would be to multiply both sides by x squared minus 6x right off the bat. And those would cancel, and 1 times x squared minus 6x is just x squared minus 6x, and so my second step leaves me with x equals x squared minus 6x. Since I have a squared, I usually need to set it equal to 0. So if I subtract x from both sides, I get 0 equals x squared minus 7x, which means if I factor out an x, I get x minus 7. So in this case, x could either be 0 or it could be positive 7. But you need to always double check and see if either one of those values x equals 0 or x equals 7 would cause this to be undefined. If you put 0 in for x, you would get 0 squared minus 6 times 0, which is 0, which would make you divide by 0 and make it undefined. So this cannot be one of your solutions. Only x equals 7.